How are you? In today's episode, we'll see the scene together. What would it look like if we went from Earth to space at the speed of light? We'll also calculate how long it would take. But before we begin, let's define space. Where does it even begin? Planet Earth is inside space. But as far as we're concerned, we live inside planet Earth and its atmosphere. If we want to go into space, we have to keep going up until we get out of the atmosphere and into space. But I wonder how far we need to go to be able to say we're in space. To answer this question, we need to study our atmosphere because it is the boundary between us and space. Earth is a solid surface with several layers of gases above it. The air is called the atmosphere and surrounds Earth, all of it from all directions, and first it has a layer in it. It's called the troposphere, and it extends from Earth to 15 kilometers. Almost everything happens there because it contains 80% of the mass of the entire atmosphere. It contains high levels of oxygen and nitrogen, which are essential for the respiration of organisms and plants. It also where all atmospheric phenomena occur, such as sheety clouds, rain, lightning, and thunder. All civilian aircraft fly in the outermost layer of this layer, at an altitude of 10 to 12 meters. The layer beyond this is called the stratosphere. It extends from 15 to 50 meters, and it contains the auroral layer, which we've perforated. It absorbs harmful ultraviolet radiation from the sun to protect the planet and living organisms from its harmful effects. This layer includes military aircraft, reconnaissance aircraft, and weather balloons. The next layer is the mesosphere, which extends from 50 to 85 kilometers and is characterized by its very low temperature, which reaches -90 degrees Celsius, and the air is very thin. This is the layer that protects us from the danger of meteors and comets, as they burn up in it before reaching Earth's surface and cause meteors to appear in the sky. The next layer is the troposphere. It extends from 85 meters to 600 meters. This is where the aurora borealis occurs. It is a collection of stunning green, red, and purple lights. It appears in the sky near and at the poles. The last layer of the atmosphere is the exosphere. It is considered the weakest layer in the entire atmosphere. It extends from 600 meters to 10,000 meters. It contains very few atoms and is very well separated from each other. It gradually disappears into space until it disappears completely. So, what does this mean? The beginning of space is 10,000 kilometers away. The answer is no, because orbiting vehicles, such as satellites and space stations like the International Space Station, orbit Earth at a distance of 400 kilometers, which is within the thermosphere. These vehicles are considered spacecraft, and this is because 99% of the atmosphere's mass is found in the top 50 meters, which is the troposphere, stratosphere, and other layers. They represent no more than 1% of the atmosphere's mass. This makes the air in them very thin, and the atoms are very far apart, just like space. That's why the line between the atmosphere and space was defined as an altitude of 100 meters, called the Kármán line. At this altitude, the air is very thin and cannot be flown using wings or relying on airlift. Rocket propulsion is required to reach orbital speed. You're a spacecraft, not a ground-based plane. And since you're a spacecraft, you're technically in space. An altitude of 100 kilometers was adopted as the boundary between the atmosphere and space. Let's begin the experiment. Now we know that we're supposed to go 100 meters up to be in space. We're now somewhere on the surface of the Earth. I'm not going to tell you. Try it. Find out where we are and write to me in the comments. The important thing is that there will be an altitude bar here, which will tell us exactly how high we are. This will be the speed at which we're traveling. This will be the timer. Let's begin. The experiment is at a speed we've all tried before, at 100 kilometers per hour. We'll take off. After 3, 2, 1. You can see, we started climbing upwards at a speed of 100 meters per hour. It's clear we're in a village, rural. Can I also show you the view from every side so you can see where we are and in which country exactly? And we're still climbing upwards, one by one, amidst the green mountains and lakes. And the view from up here is, frankly, absolutely stunning. It's truly magnificent and beautiful. Glory be to God who created all this beauty for us and also created for us the atmosphere above us with all its layers to protect us from all the dangers coming from space and to keep our lives safe and prosperous on this wonderful planet. As you can see, we're about 40 seconds up and didn't move. At the altitude bar, except for a very small thing. And that's because it will take us a full hour to reach. We don't go up to 100 meters and remain in space. Of course, it doesn't make Since that sit for a whole hour watching, so let's go back again and increase the speed even more. And this time we go up at a speed of 900 meters per hour, which is the average speed of civilian aircraft. We'll take off after 3, 2, 1. As you can see, there's a very clear difference in speed because we multiplied the speed by 9 and began to see areas, lands, and mountains farther away. And also to get closer. We reached the first layer of clouds. And as you can see, the bar of height is moving a little higher than before, but it's still moving slowly. And if you notice, you'll also find that the closer we are at the Earth's surface, the faster we feel the speed. But the higher we go, the slower the speed becomes. This happens because of something called references visual objects close to you, because when you're walking fast in or near the ground, there will be trees, buildings, cars, and many visual objects close to you. And you'll see them moving very quickly around you. Because you're walking fast, your brain automatically gives you a feeling that you're moving very fast. But the higher you go, the further away you get from the visual objects. There aren't many things around you that make you feel your speed, except for the clouds, which are very large and also very far apart. In this case, your brain feels like you're moving slowly, and you can see that we passed the first layer of clouds, and they looked like smoke from the inside. We're currently traveling at 900 kilometers per hour. And we want to cover 100 kilometers, so it takes approximately 7 1/3 minutes. They've passed about 1 1/3 minutes, and there are 5 1/3 minutes left. Of course, we won't wait all that long and then return to the starting point, but this time, we'll go at a faster speed, which is speed of sound, which is 1,235 kilometers per hour. We'll take off after 3, 2, 1. As you can see, it's a very fast launch and a loud sound. The loud boom you heard is the breaking of the sound barrier. Of course, this sound is supposed to bite comes out from behind us, and we don't hear it. But to heard it for you to ask you a question, and I'm waiting for your answers in the comments. What is sonic? This boom or popping sound happens upon arrival at the speed of sound. Whoever answers this question correctly and knows exactly which country we're in will get out. It turns out the name of the next video and what we'll implement. An idea he suggests. And as you can see, we're going up, and we've quickly passed the first layer of clouds and are entering one after it. And the altitude bar is moving a little faster than before. But we still have a few more minutes to go until we arrive, so come on, we're going back, and this time we're going to take off at the speed of an airplane. The Concorde is almost twice the speed of sound, to 180 kilometers per hour. Come on, let's go after 3 to down, a very fast takeoff. And like what are you seeing? Entering the first layer of the clouds at a very high speed. Of course, for those who don't know, the Concorde is the fastest passenger aircraft in history. It entered service from 1976 until 2003. It flew at higher altitudes than all other aircraft, at 18 meters in the stratosphere. It was a very luxurious aircraft, reaching its destination much faster than other aircraft. However, it was discontinued in 2003 due to the accumulation of many problems, the first of which was the accident of the Concorde in 2000, which killed all the passengers on board. This is in addition to its extremely high operating costs, which cost many times more than operating a regular aircraft. It also had more passengers, and the Concorde was a luxurious aircraft. Its tickets were very expensive, and demand for it was nothing, not to mention the extremely loud noise. It's caused by the sonic boom or the boom, the sonic boom, and also the Concorde fleet. It was old, dating back to 1976, so maintenance costs were very high, and spare parts were scarce and unavailable. All these problems caused the Concorde to be taken out of service in 2003. As you can see, we went very high this time, and the atmosphere began to get very thin, and the blackness of space began to appear. But, as you can see, in a bar, we still have about half the distance to go. So let's go back again, and this time we'll increase the speed. The speed is absolutely insane, and we'll reach 11,800 kilometers per hour, which is the speed of NASA's X-3. Let's single quotes as takeoff after 3, 2, 1, or a very, very terrifying takeoff speed. And in seconds, we went very high. And as you can see, BART altitude is moving quickly. And in less than 10 seconds, we'd have passed all the cloud layers. NASA's X-43, which flies at this speed, is an unmanned aircraft powered by an engine called a scramjet, and it's considered the fastest aircraft in history. It's powered by an atmospheric jet engine, not a rocket engine. As you can see, in about half a minute or 30 seconds, we'd have reached the beginning of space, at a line 100 meters above the Earth's surface. If we were to look down toward the Earth, we wouldn't be able to see any cities or anything, just a group of mountains very far away from us, and the view from here is, frankly, extremely beautiful. Okay, let's go back. We'll pick up speed a lot, and go up at 28,000 kilometers per hour, which is the speed of the International Space Station. We'll be there in 3 minutes. Once you can see, the speed has become incredibly terrifying. To the point that we cover tens of kilometers in seconds. We reach 100 meters in 13 seconds, just a thought, when we travel at 61,000 meters per hour, which is the speed of Voyager 1, we'll reach it. How far? Let's try and see. After 3 to 1 you reached it in just 6 seconds. Let's try it. The fastest speed humanity has reached so far is the speed of the solar probe, which reached 692,000 per hour. Let's go after 3 to 1, and we reached it in less than 1 second. That's because at this speed, you could complete a complete lap around the entire planet Earth in 3.5 seconds, but the speed of light is in a second by itself. Because it reaches approximately 300,000 kilometers per second, or the equivalent of 1,079,251,200. How many hours, at this speed, can you travel around the entire planet Earth 7.5 times in only a second? Let's see the speed of light. After 3, 2, 1, as you can see, and as it is. It's as if we've moved instantaneously from Earth. Of course, the distance to space is very small, only 100 kilometers, and the speed of light is too high for it. So let's go. To feel the speed of light, we need to go farther. You can see the small white dot. That's Jupiter. Let's go towards it at the speed of light and see how far we can get. Okay, we'll remove this height bar. We don't need it now. Let's go. Oh, we've reached Jupiter instantaneously too, without passing any time, even though it's an average distance from us. 778 million meters is the distance light is supposed to travel in 43 minutes. How did we get here? Instantly, without any time passing, just like you can see the view from here. The sun is very small, because we're so far away, and also the moons, the 95 Jupiters are scattered everywhere. Glory be to God. God, what a wonderful and magical sight. Okay, let's try it. Let's go to a place much, much farther away, which is the Andromeda Galaxy. This is about 2.5 million light years away from us. Let's go after 3, 2, 1. God. We also arrived there instantly, even though it was supposed to take 2.5 million years to reach us. So what's the story? To know the answer to this question, we must go back to Einstein's theory of special relativity, which states that the faster you travel, the slower time relative to you becomes. When you reach the speed of light, which is the fastest speed in the universe, time slows down dramatically, reaching 0. This means there is no time at all. Therefore, we can reach any place, no matter how far away it is, instantly, without realizing any time passing. However, for those on Earth, time passes normally and they monitor our journey. This is the one who will sense the time it takes us to reach it. This is the time it takes for us to reach Jupiter, which is the time it takes for us to reach the Andromeda Galaxy. This is the time it takes for us to reach Jupiter, which is the time it takes for us to reach Jupiter, which is the time it takes for us to reach Jupiter. This is the time it takes for us to reach Andromeda Galaxy, which is the time it takes for us to reach Andromeda Galaxy. But this also happens when your speed increases significantly. Time slows down, which is the contraction of length in the direction of your movement. For someone observing you from outside, the closer you get to the speed of light, they will see you shrinking in the direction of your movement. Your movement until you reach the speed of light will then be your height relative to them will be 0. In other words, you will no longer exist at all, but relative to you. The closer you get to the speed of light, the more you will see that the entire universe is contracting around you into a single point in front of you in the direction of your movement. As soon as you've reached the speed of light, space will be 0, time will be 0, meaning that all the places in the entire universe that you could possibly go to will be contracted in front of you into a single point, and all time, the past, present, and future will be frozen relative to you at a single moment, or in other words, you will be in all places, all times. At the same time. If you want to understand more about this topic, watch this video. See you next videos. Bye.